Hello everyone, welcome to the chemistry class. Today we are going to discuss chapter 1 of chemistry, chemical reactions and equation. We'll take the topic types of chemical reaction. First is combination, second is decomposition, third is single displacement, fourth is double displacement, and the fifth is redox reaction. We'll discuss their definition and the examples. See the first one, combination. As the name suggests, combination means combine. In these type of reactions, reactants combines to form the products. You can see the definition. These types of reactions occurs when two reactants combine to form one or more products. Examples, CaO plus H2O. These two reactants are combining to give only one product, CaOH whole twice, calcium hydroxide. Second example, carbon plus oxygen combine to give carbon dioxide, the simplest example. And the next is, these reactions are usually accompanied by the evolution of heat, and the reactions in which heat is produced are called exothermic reactions. Exo means exit, thermic means heat. So the reactions in which heat is produced are called exothermic reactions. So these reactions are generally exothermic reactions which involves the evolution of heat. The next type of reaction is decomposition reactions. Decomposition reactions are the reverse of combination reactions. In combination, two reactants were combining to give the single product. In decomposition, a single reactant decomposes into simpler products. So the types of reaction in which the single reactants breaks, decompose down to give simpler products. These types of reactions are called decomposition reactions. One of the simplest example, water is produced by the reaction between hydrogen gas and oxygen gas. So water on decomposition gives us hydrogen plus oxygen gas. See, to break any compound, we require the energy. That energy can be provided in the form of heat, can be provided in the form of light, or in the form of electricity. So decomposition reactions are further divided into three categories. First one is thermal decomposition. Therm means heat. So when the decomposition is carried out by using heat, it is called thermal decomposition. And when the decomposition takes place by using electricity, that is called electrolytic decomposition. And if the decomposition takes place by using light, that type of decomposition reactions are called photolytic decomposition. Photo means light, lytic means breakdown. See the examples of decomposition. First is hydrogen peroxide, H2O2, decomposes to give H2O plus oxygen. This reaction takes place in the presence of light. So this is an example of photochemical decomposition or photolytic decomposition. Then water decomposes to give hydrogen plus oxygen. This decomposition requires electricity. This is called electrolytic decomposition. Third example, nitrogen iodide decomposes to give nitrogen and iodine. This reaction requires heat. So this is an example of thermal decomposition reaction. And in general, we represent decomposition as AB. Any compound decomposes to give A and B. Next type of reaction is displacement. Displacement, as the name suggests, replace. One thing displaces the other. So a more reactive substance displaces a less reactive element. So the reaction in which a more reactive element displaces a less reactive element from its solution. We have to take the solution of a less reactive element, and when we add a more reactive element to it, it will displaces the lower reactivity element. They are of two types. First is single displacement and the second one is double displacement. See their examples. Single displacement reaction. First, magnesium plus copper sulfate gives us magnesium sulfate plus copper. Magnesium is more reactive than copper. So magnesium will takes the place of copper and copper will be separated out from its solution. So the product is magnesium sulfate MgSO4 plus copper. This is an example of single displacement or single replacement. See the general form of it. A plus BC gives AC plus B. A displaces B from the solution of BC. So the product is AC plus B. Double displacement reaction or double displacement replacement, one and the same thing. Calcium carbonate plus HCl gives calcium chloride plus carbonic acid. Calcium combines with the Cl and hydrogen combines with the carbonate part. So here two substances are displacing each other. Calcium takes the place of hydrogen or hydrogen taking the place of calcium. So the products are calcium chloride and hydrogen carbonate. General form you can see A plus B, AB plus CD gives AD plus CB. A takes the place of C and C takes the place of A. So if two substances are displacing each other, that is called a double displacement, and if one substance is displacing the other element, only one, then it is called single displacement reaction. Single displacement reactions follows this reactivity series. In this series, the elements are arranged in order of decreasing reactivities. See, first element is potassium, the most reactive. Then comes sodium, less reactive than potassium. Then calcium, less reactive than sodium, and so on. And last one is platinum, the least reactive element. So we can judge which element can displaces the other one from this series. So the topmost element can displace the lower elements, but the lower elements, they are not able to displace the higher elements. That is, see the figure, calcium is more powerful than aluminium. Calcium is at the top and aluminium comes below it. Calcium can displace aluminium, but aluminium cannot displace calcium. So the upper elements can displace the lower elements, but the lower elements cannot displace the upper elements from their solutions. So this reactivity series helps to tell us which reaction will take place and which one will not take place. The last type is redox reactions. Redox, as the name suggests, the name actually consists of combination of two things. Red word comes from reduction and ox word comes from oxidation. So these reactions are basically of two, oxidation and reduction. So if a substance gains oxygen during the reaction, it is said to be oxidized. Gain of oxygen is called oxidation. Loss of oxygen is called reduction. And if in a reaction, oxidation and reduction takes place simultaneously, that reactions are called redox reactions. See the example. Copper oxide plus hydrogen gives copper plus water. Copper oxide changes to copper. That means oxygen is lost from the copper oxide. Copper oxide is getting reduced. On the other hand, hydrogen gains oxygen. Hydrogen is getting oxidized. So in this particular reaction, both reduction and oxidation reaction takes place simultaneously. That reactions are called redox reactions.